Section 9.3.11. The following data represent the pH of rain for a random sample of 12 rain dates on a particular region. A normal probability plot suggests the data come from a population that is normally distributed. A box plot indicates there are no outliers. The sample standard deviation is S, which is equal to 0.329. We want to construct and interpret a 99% confidence interval for the standard deviation pH of rainwater in this region. So therefore, there is our values there. So what we want to do is we first need to identify, a few different things. Well, we know that the degrees of freedom is going to equal the sample size minus 1. The sample size is 12, and 12 minus 1 is going to give us 11, since there's a sample of 12. And then what we know is that S, which is the sample standard deviation, not the variance, is 0.329. And we want to construct a 99% confidence interval. So if we want to construct a 99% confidence interval, in order for us to find alpha, it's going to equal 100% minus 99%, which gives us 1%, which is 0.01. And then we're going to take alpha and divide it by 2. So 0.01 divided by 2 is going to equal 0.005. So what we want to be able to do is we want to be able to find the critical value for chi-square that has an area of 0.005 and the degrees of freedom of 11. So let's go ahead and use our table. So we have a degrees of freedom, which is 11, and the area of 0.005. So there's the area of 0.005. And so we have 26.757. Now if we wanted to use StatCrunch, and so we're looking for the degrees of freedom, that's 11. And we're looking for the area of 0.005. And therefore that gives us the same critical value of 26.757. So now that we know what our values are, we know that n is equal to 12. We know the standard deviation is 0.329. And we know our critical value, our chi-square critical value, is 26.757. So when we're finding the lower bound, we're going to take n, which is 12, and subtract 1. Now, since this is the standard deviation, we need to take 0.329 and then square it to get the variance. And then we're going to divide it by 26.757. And so let's use our calculator here. So if we want to use our calculator, we're going to take 0.329 and we're going to square it. And then we're going to multiply it by 12 minus 1, which is 11. And then we're going to divide it by 26.757. So let me copy this result here. So what we're going to do is we're going to take this value here that we get, and we're going to round it. So right now we're going to get 0.044499. And I'll get back to you as to why we are rounding it to that many places. Now we want to find the upper bound. So the upper bound, again, we know the degrees of freedom is 11. We know that our standard deviation is 0.329. We know that alpha divided by 2 is equal to 0.005. And so we want to find the critical value chi-square where it's 1 minus 0.005, which is 0.995. Okay, so we know our degrees of freedom is 11, and we have 0.995 as the area. So let's go ahead and find that critical value for chi-square. Here is 11, and we have 0.995. So we get the critical value of 2.603. So we have 2.603. Okay, so we know what n is, we know what the standard deviation is, and we know what the critical value of chi-square is. So let's go ahead and put it in our formula to find the upper bound. So we know this is 12 minus 1 times 0.329 squared divided by 2.603. Okay, so let's put that in our calculator. So we have 0.329, we're going to square it, and then multiply it by 12 minus 1, which is 11. And we're going to divide that by 2.603. Okay, and let's go ahead and copy that result. We're going to round this number to 6 decimal places. So we're going to get 0.0 or 0.457415. Okay, so now if we go back to the question here, it's asking us to find the interval for the standard deviation. Okay, right now these numbers represent the variance. Okay, so what we want to do in step 6 is we want to be able to find this interval. Okay, and this interval suggests that we need to take the square root of the lower bound, okay, and that's going to be in between for the standard deviation, and that's going to be the square root of the upper bound here. So the lower bound value that we have is 0.044499. And the upper bound is 0.457415. So when we take the square root of the lower bound number and round it to 3 decimal places, we get 0.211. And when we take the square root of 0.457415, round to 3 decimal places, is 0.676. So therefore, we're going to say that there is a 99% confidence that the population's standard deviation is between 0.211 and 0.676.